Hi there, everyone. Next speaker is Dr. Sebastian Siglock, and he's the head of data insights at Switch, which is the Swiss National Research and Education Network. And really, hi, Sebastian, that's something that is very much the equivalent of HEAnet actually here. Sebastian's got a long track record in delivering IT projects and data analysis for academia. Great to have you. Thanks very much.
Yeah, thank you very much. First of all, I'm very sad that I'm not at the location with you, and rather to the need to participate virtually. But I hope it will be interesting to you in any case. So I'm going to first share my slides. Now, can you see them in full screen mode? I guess you do, because I see this in the background. So I've been invited by Roberto Sabatino, who's working at HEAnet. Yes, I will provide a view on the topic on what we are doing at the Swiss National Research and Education Network. Basically, my objectives for today is just to provide you with an overview of a big project that we are doing, and to give you some demonstrations and also some inspirations on various data use cases we are working on. And hopefully this can lead as an invitation to some discussions around this. Actually, the project I'm going to present, I presented this in 2019, back when it was an idea at an HEAnet national conference. I don't know if some of you participated there, but if you do, this might be somewhat back in your mind. So the background of this is essentially a problem that we've identified in Switzerland. And the problem was the people told us, researchers and students at the various institutions, they said to us, okay, I don't know where to find data for research. I don't know where this data is. I don't know how to access it. I don't know what the quality of it is, etc. And this led us then essentially to consider some kind of a solution to address this problem. So how can I find what is out there? And how this fits into the overall picture of what a National Research and Education Network is doing is essentially we are making a use of the underlying network and security infrastructures. We are making a use of the cloud infrastructures. We are making a use of the identity and access management, and we link data and build new services with this. So if I go into more detail, it all starts essentially with providers of open data. This could be repositories, this could be archives, the government data, this could be library data. And what we do is we first aggregate this data, or then we pre-process it, harmonize it into one structure, we enrich it, we validate it, etc. So a kind of a similar process to what you've seen earlier today with the presentation of OpenAIRE. The metadata is then in an RDF structure. This must means it's the direction of the semantic web, and we have a metadata graph with this. What we do with this graph is we build an index, and we also build a vector database so that we can use this metadata in the language model. And all of this then becomes accessible through an API so that various service providers they can reuse this metadata. I will show some examples of use cases in the data enrichment section and some in the data service provider section. And I will give you a demo on the Open Data Navigator and the demo quickly also on the interface, for those of you more interested in the data itself. So for the data enrichments, what we basically do is we transform a metadata from various formats and structures into a linked open data. You see some examples on the screen. And what we've seen very early on is that the quality of this metadata tremendously varies. So there are a lot of the quality issues ongoing. There are a lot of interoperability issues, and so one big part of what we are doing is basically bringing the community together, defining what is needed, and essentially step by step increasing the quality of metadata. This is a use case that we have with Memoriaf and the Dash. Memoriaf is basically a society that aggregates the cultural heritage information, and the Dash is a competence center on the digital humanities. And what we do for them, I will also show this later, is we take their metadata, we do some unnamed entity recognition on this metadata and this ambiguation against Wikidata, so that we can enrich this data with location information, organization information, and person information. And in the example of Memoriaf, they are using this then to build interactive maps on their platform. This is another example from SCHUF. SCHUF is a medical library in Switzerland. They are building this a new tool at the moment. This is essentially a generous interface to explore, basically medical objects. And they are interested in displaying open research data in this platform using topic mapping enrichments. I will show later on in the platform what this is. Then another use case is with the Federal Office of Statistics in Switzerland. They have a platform that aggregates all open government data in Switzerland. And we essentially take this metadata and link it then to open access the publications in the area of health and energy data. And then there's a project going on in Switzerland where we participate. The project is called Openness Score. And the idea is basically to read from publications what the kind of what data sets and other publications have been used to produce a publication, and to derive then an openness score as a kind of evaluation on how open a given publication is. We are also collaborating with SLSP. Some of you might know them. SLSP is the Swiss library service platform in Switzerland. They Swiss Discovery as the national platform basically aggregates all the bibliographic resources of approximately 500 libraries in Switzerland. And what we collaborate on is the co-creation of a centralized access to scientific resources. So bringing this also to data sets, bringing potentially related government data sets into those catalogs, and that to the end are users of these various search and discovery solutions. With this, I go into the demo of the Open Data Navigator and the API. So I need to change my screen share. Just a second. So I guess you see all my browser now. So what you see there is essentially a data service that we are building together with the community. It's still in beta mode, which means there are still some issues that need to be resolved, but nevertheless, I guess it's a very interesting to show you this. So if I'm searching for something, just maybe social robotics, what you get is in principle what you know from many other platforms. Also, you get articles, the projects, etc. It could also be data sets. This is now all being fed essentially from the knowledge graph. And what you see there in the middle is basically resources coming from the graph. And on the right-hand side, you see resources from the language model. I will show later on with some examples of why there's a bigger difference. So if I go into an object, basically what you get from the graph, in addition to what is known, is there some related resources that are also in the graph, and you get these AI suggestions that essentially do not look at the semantics, they look at the language similarity of the certain descriptions. So we've trained the language model on using the abstracts, on using descriptions in data sets, and basically the titles. What we can also do then from the graph is build up a graph of people, or in this case, co-authors. So we know that David Cipher is collaborating with Christine Skinner, and since Christine is collaborating with a group of researchers, one can then derive, okay, for this person, this group might then also be interesting what to look at. Maybe some other things I can show you is also with some problems we are facing. So if I take everything at the moment, which is visible on this platform, you see it's roughly 3 million records. So this is not a lot. If I go on with some examples for organizations, and I just browse through this, okay, I probably should look for something. You see, for example, that an Hydro Eco conference is classified as being an organization, and this is precisely what I meant is a data quality issue, because from the source where we got this data, it's classified in this way. And so there are a lot of data quality issues that need to be resolved. If I look at a specific provider, so for example, I take Zora. Zora is the repository at the University of Zurich. Then I can generate a topic map. This is now basically using the language model and looking at the various resources within the repository, and providing a clustering on topics that are present in this repository. So you see that within the university, there's a lot of research going on cancer, which is a good sign. And also then obviously all these different topics, and I can then also compare to different repositories in Switzerland. So for example, this one from the University of Lucerne in Switzerland was very interesting because they seem to be actively present in researching on Buddhism. And it turned out that they are basically running a journal on this topic in Lucerne. If I look for a data set, I search in German now, and I take just a moment. You see that there are some issues that are going on. So if I take this data set, this is now a data set, a government data set from the state of Grisons in Switzerland. What is important to us is that we can always link back to the source. So there's the location of the data set, but I can also download the data set if I want to get it directly for the use as a researcher. And I can then also see obviously the related resources, suggestions, etc. of the data set. In the preparation of this talk, I thought, okay, can I show something that seems to be related to Ireland? And what I did is I translated a query into Gaelic using ChatGPT. So I translated war, propaganda, Russia, and Ukraine. I did this because I know that there are no information in the knowledge graph on this. So if I search for this now, you see precisely this. There are no results in the graph, but the language model can still provide some results, and it doesn't care about the different languages. So you see there is a result in French. There's a one in German. It could be whatever kind of a language. So this is a different kind of exploring data that has been structured in the graph. And maybe lastly, something more exploratory is this ask the feature there. Which is also making a use of this language model. So if I query, for example, like how do I study trees? Then it basically provides me, it learned from the abstracts of the publications and the data sets, and it provides me, okay, I can study trees by aerial photography and deep learning, by reflectance spectra, and by accurate tropical forest delineation. Yeah, so these are the things we are working on. I can also show you this briefly in the API. This is the way it looks like. So this is the way people can then reuse the data for their purposes. So I can search, for example, for an article on artificial intelligence. I get the results, and this can then be used from the developers to enrich their own tools. And also this might be interesting. I mentioned the example before where we did the named entity recognition for Memoriaf. And this is precisely what you see there. It's basically a query that looks at the provider memo base and then gets the additional geo coordinates on this. And with this, I'm changing back to my slides. Just a moment. Yeah, so to summarize, the added values of what we are doing is basically we are working on increasing the data quality and the interoperability. We improved the discoverability of the resources that exist in Switzerland across the various tools and services so that other people can use this. And by using tools like these AI suggestions or topic modeling, we can improve the value by bringing additional views onto the same data, basically. We structure in project governance, which means that all the members that are participating, they also participate in the decision making. So they propose and decide upon what features to implement, what new data sets to implement, etc. How do we relate to the European Open Science Cloud? So we are a member of the EOSC Association. My team is also participating in 2 task forces. One is the fair metrics and data quality, and the other one is the semantic interoperability. And based on this, we started the fair metadata working group in Switzerland with the focus on improving the data quality. And we also launched some Swiss activities towards building up the EOSC, the Federation of Nodes. I don't know how much you know about this initiative, but essentially, I assume that every country will need to work on these topics. And we also obviously consider to deliver the metadata graph towards the EOSC, our research knowledge graph. Yeah, and with this, I can hand over to a Q&A, and thank you very much for listening. I cannot hear anyone.
Yeah, we're just getting ready here.
Sure.
Yeah, sure. Okay. One question. Okay, so I'll stand at the sorry, Sebastian, just a second. There's an echo coming on here in the hall, so I'll stand at the podium and relay them to you.
You just tell us and I'll relay it, David. That's
Sure. Can you hear me?
Yes, with a slight echo.
oh, come on.
Let's try.
Hello again. So so what you're talking about, just in a nutshell, is you're taking with your portal that you were just showing us. It was a traditional faceted metadata search enhanced with AI that's taken all of the metadata into a vector database. So I'm just wondering, firstly, which LLM you're using, and secondly, I suppose you could have a scenario where you could literally chat to that LLM like you could chat to ChatGPT currently.
Yeah, so basically,
Thank you.
yes, there can be seen as a traditional catalog that is enriched. So to answer this question, I need to go a little bit into the legal side of the things. We are currently not using LLMs because we do not know if they come up with some sources that are not, legally good to use. So what we are doing instead is we are using the BERT language model. This has been developed and open sourced by Google. And this is essentially, the difference is it's not a very much generative. It's more used for Q&A purposes. We do, however, also try to bring this metadata into an LLM. So what is very much important in this context is the quality of the metadata. So I assume all of you have been using ChatGPT before, and some of you might have seen that when you ask for some literature or something, it comes up with hallucinations on some sources. And if you link an LLM to a knowledge graph, you can remove this. And so that's why the data quality and harmonization is are so important in this space. I don't know if this answers your question.
Thank you.
Yes, thank you. Any other questions for Sebastian from the floor? We've no more questions, Sebastian. So have we anybody online, Liam? So we'd just like to say thank you very much for your wonderful presentation.
Thank you very much.